So in this video here, we are going to look at what we are calling the spherical aberration. So our basic heading here, we say is spherical aberration. It may look like something which is a very new term, but it is not new. And if we are to analyze it or interpret it according to our mirror here, we are looking at spherical aberration. What we are calling aberration is all about the distortion of images. That the moment we have numbers of optical instruments that we shall be looking at. There are some scenarios where you see the image of an object you're seeing is not even at all resembling the object. In a scenario where the object and the images are different, or there is some kind of changes or distortion, that distortion is what we are calling it aberration in spherical mirrors. If it is now in mirrors, we call them aberration in mirrors, okay? But the whole point is aberration is all about the change in the image of the object not looking alike to the image you are actually observing. So now we are going to analyze it in spherical mirrors. That is the curved mirrors, concave and convex. So if they ask you what is spherical aberration, what could you actually say? We can say spherical aberration is the distortion of images in either a lens or curved, or I can just say or mirrors, but we basically look at curved mirrors of wide aperture. Okay? The change in the image, either it could be in a lens or in mirrors. We shall also analyze the detail of this when we come to lenses. Aberration in lenses. So know that both lenses and mirrors can form images which do not actually look like the object. If that is happening, we say there is aberration. If it is in lenses, we say spherical aberration in lenses or spherical aberration in mirrors. But know that it happens in all the two. But as per now that we are still talking about curved mirrors, we shall only concentrate our mind on aberration in mirrors, and then we shall analyze the one of lenses when we come to lenses. And don't forget, we are saying that the distortion is as a result of the mirror having a wide aperture or the wide surface length. Either the mirror or the lens, if it is having a wide aperture, it will result into that. And then maybe we can look at how do we now explain aberration? What we're calling occurrence. Spherical aberration in mirrors. Okay? How does it occur? We have actually defined it. What is spherical aberration? Now, what is its occurrence in mirrors? I can now make a simple sketch here. That if I have my mirror here, this is the principal axis. I have these are the marginal rays, and then I have these are the paraxial rays. They are all incident. I have this as the paraxial, these are the marginal. from the definition of marginal and paraxial rays. We said that marginal rays are reflected very close here, and this one are reflected very far, and now this one is very close here, and then this one is reflected far. Sorry, this one down here is not the order here. We are saying this one here, we are saying that this one is reflected far away, whereas this one is reflected near there. Okay, I can have something like that. So you realize that there are now two focal points. Where are those two focal points that we are talking about? There is this one here, F1. There is this one that I can call F2. All those are focal points for different rays. Like you can see, for this is what we are calling a marginal rays. Marginal ray, and this is it. So you can see that the paraxial and the marginal rays are all being brought at different points. Is that okay? So that means that we shall have an image here and we shall have an image here. Now imagine a scenario where we have also other rays here. That means that from this point to this point, there are a number of images, but the image is all from one single object. So if we have series of images of one object, very many of them, if you look at them, it will look blurred and circular. Okay? So this image here that is formed is blurred and circular. What do we mean by being blurred? It is not very clear. Is that okay? The image is not clear or not distinct, and it will be circular. And then we look at the what we are now calling the diameter of the smallest diameter, okay? That of the circle of the image that is formed here. And then we are also talk about what do we call this length here? The longitudinal aberration. And that is now coming when we are now reviewing it back in the other session of ours. But what is very important there is that you note that if we have this marginal and the paraxial, they are brought to different points. And if they are brought to different points, that means that we have number of images of one single object. This number of images, when you are looking at them, they will be circular and not clear. Now, by the fact that it's not clear, that means it's already different from the original one. And that is what we are calling a distortion. And we are calling it aberration in curved mirrors. So, what do we write about that? If we are to describe the occurrence, we shall say, when white light is incident on a curved mirror of wide aperture, comma, the marginal rays are brought to a point close to the what? Close to the pole of the mirror, whereas the paraxial rays are brought to a point far away from the pole. Okay? that the marginal are very close to the pole is here, and now the paraxo is brought to a different point. And remember, the images are formed at that point. And then we say this results into formation of circular blued image. Okay? This will result into formation of a circular blued image within that region there, what I call longitudinal aberration. The image you'll see will be circular and blued, not clears. And then you say there are a series of images of the same object, hence no single image formed of the same of a single object. Okay? So that means that in that case here, as we are saying that what will happen is that also if we had other rays here, we'll bring this image. Another will bring, that means that from this point to this point, we shall have series of images. If you look at those series of images, they will look circular and not distinct. You will never distinguish them. All of them will be representing the same object. And that's what we are calling distortion or confusion in the image of a single object. So if they tell you to describe the occurrence of spherical aberration, this is what you write basically. Talk about the marginal and the paraxo being brought at different point as a result of the mirror having wide aperture. Okay? And if that has happened, we say that the series of the images will now be circular and blued. So, after seeing that mirrors can now do that, you can also, by the way, look at maybe if it is convex mirror. If it is convex mirror, you would draw it like that because you'll be wondering, what if it is convex mirror? How do we illustrate it? We have this, we have this and that. We said that this one will be reflected to come to a point near, but this one when it is reflected, it will be to a point